Okay, hello everyone, and welcome to NG Asia. We are so glad you could join us today. We are live right here on YouTube with amazing Angular community. Today we have a very special guest, Ingila Ijas. She's a full stack developer. We are so glad 1 minute you could join us today. We are 1 minute. Okay. Okay. Today we have a very special guest, Ingila Ija. She is a full stack developer, speaker, technical writer with over 11 years of experience building B2B enterprise scale applications. She has worked in the fintech, SaaS, and the AWS cloud solutions, and she also open source contributor, truly an inspiration in our field. The topic for today's session is front end. We will explore why micro frontend architect is important, how it helps projects scale, and practical strategy for implementing it in real world application. So get ready to learn, ask your question, and engage with the community. Without further ado, let's warmly welcome Ingila Ijas.
All right.
Can-
Hello, everyone. Thank you so much for having me and for the kind words. I really appreciate take you guys taking time for joining us here today. So this session is about micro front-end architecture and its implementation. And I hope that by the end of this session, you will have a solid understanding of what micro front ends are, why they are important, how they scale, and some practical high level strategies for their implementation. So, before we dive in, let me give you like a quick introduction. So, my name is Angela. I am a consultant at Convo. I've been a coder for around 12 years now and specialized in B2B and SaaS based applications. I'm also a writer on medium.com, an open source contributor, a co host on This is Tech Talks podcast. On a personal note, I am also a mom of three, as you guys can see. And here's my LinkedIn. I'd love to connect and yeah, feel free to reach out. So let's get started. So before we actually get started, let's talk about some of the problems and the challenges that organizations and companies collectively were facing when it comes to monolithic front ends. Right. There were a lot of problems with the monolithic architecture. So the first of all, the first problem was tightly coupled components. Right. In a monolith, we had all the components that were deeply interconnected, and those components were interconnected within a single and a massive code base. Right. So this creates kind of like very tightly coupled system. So if you change one part of the application, you can trigger unintended side effects in completely different and seemingly unrelated area, right? So this makes the development very risky and requires extensive and time consuming testing across the entire application. Then there was another problem that monolithic front-end architectures actually bring within themselves, which are related more to the scalability, right? When you scale a monolithic application or a monolithic front end by running more instances, that becomes very highly inefficient. So if only a small part of your application experiences a traffic spike, you are forced to scale the entire application with its dependencies, which leads to a lot of problems. So monolithic architectures are not very good and very efficient to scale, right? Another problem that we face in monolithic front-end architectures are very slow development and deployment cycle. So When we have a single very large code base, what happens is that your build and your deployment times can increasingly become slow, and they can be incredibly long. A developer might finish like a small feature in 1 hour, but then probably they have to wait for 30 minutes for the full application to compile and deploy just to see the changes in a live environment. So what happens with that is that it completely kills the feedback loop, and even worse, the deployments become high risk events. So what can happen is that a single bug in a small feature can necessitate a full application rollback, impacting the entire user base. Another challenge that we have in monolithic front-end architectures is the technology lock-in. Um, Usually, monolithic architectures and if you talk about the front end, they are typically built on a single technology stack. So, for example, a specific version of Angular from several years ago, and because Angular is evolving and with time, it becomes increasingly difficult to introduce new technologies or upgrade the existing ones without a massive big bang rewrite or nothing effort. So this is also something that probably every senior developer dreads. Then we also have lack of team autonomy to uh, when it comes to monolithic front end architectures, which means that if there is an issue, which is obviously like a major issue in large organizations. So when multiple teams are working on the same monolithic front end, it's a constant battle with merge conflicts, right? Communication overhead and shared dependencies. A team cannot independently deploy a feature without coordinating with everyone else, which significantly hinders the agility of a team. All right. So all of these problems are very efficiently addressed with the help of a micro front-end architecture. So the micro front-end architecture, or the concept of micro front-end architectures, was first introduced by ThoughtWorks in 2016. Micro front-end architecture is an architectural pattern that is modeled on the basic mental model of microservices. However, this is for the front end. So the idea is simple, but it has a very revolutionary impact. What the idea suggests is that instead of a single large front end code base, a web application should be composed of multiple smaller and self contained micro front ends. So each micro front end can be of a different technology, and each micro front end is responsible for a specific business domain or feature. For example, like a shopping cart, a user dashboard, or a product recommendation module, something like that. We can add as many examples as we can. If you look at the architecture of the micro front ends, is every micro front end, regardless of the technology, they have their own CI/CD pipeline. They have their own home in the production. But when it comes to the exact UI, they are combined, or they are coupled together or bundled together um, in the form of one single application. So one of the biggest benefits that we get from micro front ends is obviously the team autonomy, which means that each team has full ownership of its micro front end, from development to deployment. Um, that team is responsible for their chunk of the micro front end, and this eliminates bottlenecks and allows the team to work at their own pace. Which is a crucial benefit for especially for large enterprise scale business B2B applications and SaaS application, where velocity is the key and a very differential factor. Then we also have loose coupling as opposed to the monolithic front-end architectures. Each micro front-end is developed, tested, and deployed independently. So this minimizes the risk of a change in one module having any impact on the other. This allows for more confident and isolated deployments. Then obviously, when we have all of these benefits coming from the micro front end architecture, we have rapid or accelerated deployments and development, which means that teams can deploy their micro front end on their own schedule without a large coordinated release. This enables continuous delivery and significantly reduces the mean time to market for a new feature, because because the development and the deployment increases and is become and becomes independent of other dependencies that might be in the system. Another big advantage of having a micro front end architecture is the technological flexibility that we get. Because front end frameworks are evolving over time, we are not we don't have to stick to one particular version of a framework in order to build any new feature. We can bring in another technology, and we can bring in diversity and innovation in our micro front end architecture, in our overall application, with the help of micro front end architecture. So different micro front ends can be built using different frameworks or different versions of the frameworks. Um, the benefit that it gives is that it allows teams to choose the best tool and for the job, and experiment with the new technologies without affecting the entire application. It also enables gradual upgrades, such as migrating a legacy part of the application to a new framework, one micro front end at a time. You know, so ultimately, the smaller and more focused code bases are easier to understand, test, and maintain. And a single change to a small part of the application no longer requires a massive, risky redeployment of the entire front end. Okay, so now let's me go through some of the implementation strategies. Then, now that we have covered the advantages and the challenges that monolithic architectures used to bring, there are a few strategies which we can use to implement micro front ends. So one of the most famous ones is mono repository. So in mono repository, in the setup, all the micro front ends in a single are residing in a single repository. And while it may seem a little opposite or counterintuitive to the micro front end philosophy, it offers unique advantages. You get centralized dependency management. You have easier collaboration because all the projects are visible to everyone, and you have consistent tooling across all the micro front ends, right? However, this introduces some level of complexity, and as the number of micro front ends grows, and it still presents challenges for efficient builds and deployments. So um, when you are considering a monorepo, you are when you need to there are scenarios where you need to use a monorepo, right? So a monorepo is best suited for scenarios where you are in a smaller to medium-sized organization with fewer teams. The complexity of a single repository is manageable, and you avoid the overhead of multiple repos. Okay. And then code sharing is a top priority. For example, um, if your micro front end needs to share a lot of common UI components, a core design system or utility functions, a monorepo simplifies it all. You are working at the same pace, so code sharing is as easy as an import. Okay. So yeah, monorepo provides really great benefits like centralized dependencies, easier collaboration, consistent tooling, but there are consideration that you need to have. As the number of micro frontends grows, the managing the monorepository can be difficult and it can become complex. Building and deployment challenges also are something that we need to ensure that the efficient builds and deployments for all micro frontends um, are a challenge when we are working on mono repository. A multi-repository is another strategy that we need to that we can implement our micro frontends in. With a multi-repository approach, what we can do is that each micro frontend lives in its own separate repository. So this provides a complete isolation, allowing teams full autonomy over their projects. Now, this approach is highly scalable, and adding new micro frontends is straightforward um, as compared to the mono repository approach. The main consideration, however, here are the complexity of integrating multiple repositories and the careful version management needed to ensure dependency, complexity, compatibility across different projects. There are scenarios where you can use multi-repository, and you can use this strategy when you have many large and independent teams. So if your team size is huge and you need to make sure that your teams are independently working, this approach gives each team a complete ownership of its code base and its repository. So there are no bottlenecks or merge conflicts that happen a lot of times when we're using mono repository, because teams are not interfering with with each other's work. Now, another another use case for using a multi-repository can be when you have teams that need to choose their own frameworks or libraries, as multi-repository gives complete freedom to innovate without affecting any part of your code base. Another use case can be security scenarios where security and access control are critical. So if you have sensitive code bases where you need to have um, restrictions, you can easily restrict access to specific repositories, which is a significant advantage from a security endpoint. Another one of the use cases that we can use to implement micro frontends using a multi-repository approach can be when you need to scale the teams and projects independently. So if a new team member is onboarded, a new micro frontend is as simple as creating a new repository basically. So this model is built for independent growth. There's another model that is kind of like a balance between both monorepo and multi-repo, which is called meta repository. It involves having multiple repositories for individual micro frontends, but also integrating them into one central repository. So this is kind of like a hybrid approach, and it offers a balance between the centralized control of a mono repository, but the flexibility of a multi-repository. It is a great choice for organizations that want the best of both the worlds, that want both centralized control as well as some level of flexibility in their multi repository. So now that we talked about the strategies to implement micro front end, what we can do, we can move to the best practices when we are working on micro front end. So one of the key considerations or one of the best practices that you need to make sure and stick to is that you establish clear module boundaries. So when we are implementing micro front end, you need to ensure that you have established very well defined boundaries for each micro front end, and that clearly we need to define clearly what a module is responsible for and what it should not touch. So if a module responsible for feature A, it should not have any impact on feature B, and it should not touch any dependency of feature B. So the module boundaries should be very, very clear. Uh, it promotes encapsulation and it reduces unintended dependencies between models, right? Then we have independent deployment. We need to encourage our teams to develop their micro frontends autonomously, so that each module should have a team responsible for its full life cycle, from development to deployment. This is the key to reducing team dependencies and streamlining development processes. One of the most important consideration when we are implementing micro front ends is to ensure consistency in the UI and UX. What happens usually is that because the frameworks are consistently growing, it can become challenging to make sure that those elements or those UI UX are consistent and they look seamless and the user doesn't get and the user experience is not affected. So with different teams, then when they are working independently, maintaining a uniform look and feel is a significant challenge. And to solve this, you need to have like a shared design system that serves as a single source of truth for all the components. Um, Using scoped design styling methodologies like CSS modules or CSS in JS is a critical practice to prevent styling conflicts. Okay, so there are three ways to implement micro frontends. So the first one is module federation. So module federation is a very powerful feature in the Webpack 5, and that allows you to share code between separate applications. In its simplest form, what we can in a very brief or simplest form, we have a host application, and we also have a remote application. So the remote exposes modules for consumption, and the host uses a shared configuration to dynamically load them at runtime. The real magic is how it manages the dependencies. So if the host and remote both are using React, for example, or Angular, for example, module federation ensures that React or Angular is only loaded once, avoiding redundant code and version conflicts. So, yeah, a module federation applications in any module federation application, there are four main components. We have a host or a container, which is the currently running application that is hosting the federated or remote modules. We have remote modules, which are independent micro front ends, which are encapsulated or which are rendered on the inside the shell. We have expose, which is a module that is exported from the applications, is exposed to other applications for consumption. So this option is an object that lists all the modules that the remote application is exposing to other application, and the key in this object is it represents the module names and the applications that can use to share the modules, and the values are the paths to the modules in the remote application. Now the shared module is a module that is shared across different remotes. So this option is an object that lists all of the modules that the remote application will share with other applications. The keys in this objects are the names of the shared modules, and the values in this objects are the ones that contain various configuration options. Another way to implement micro frontends are native federation. Native federation is a most modern and browser native implementation of the same mental model that module federation was built on. It relies on modern browser technologies like ECMA script modules and import maps, which means that it can be used independently of specific build tools and frameworks like Webpack. Now, Native Federation has a two-layer approach. Uh, with its core, it's it consists of two layers, right? So the lower layer is called the Native Federation core, and we also have an integration layer. So the core Native Federation core is a build tool agnostic, and it can therefore be used in all possible environments. In order to simplify the use of Native Federation, we have another layer which is called the integration layer. Um, we have integration layers for Angular CLI, and we also have integration layers for React. But you can also develop your own integration layers and add that into the Native Federation project, which is very much possible. Another approach to implement micro frontends is a single SPA. Now, a single SPA is a JavaScript framework that is specifically designed for front-end microservices. It helps combine multiple applications, potentially built with frameworks like Angular, Vue, or React, into one seamless experience. So, single SPAs acts like a lifecycle manager, enabling each micro frontend to be dynamically loaded and unloaded based on the routing configurations. Um, Before we dive into the challenges, let me first talk a little bit about the single SPA component. So we have in single SPA, we have a root configuration, which is responsible for rendering the HTML page and registering the applications. Now, each application in a single page, in a single SPA based application is comprised of a name, a function that is to load the application's code, and a function to determine when the application is active or inactive. Now, those applications are actually micro frontends functioning as SPAs packaged into modules. Now, each application must implement its own methods to bootstrap, mount, and unmount itself from the document object model. So, the core concepts of a single SPA are the application registration, in which we register each micro frontend as an application, as an independent application. We have lifecycle methods, in which each micro frontend has its own lifecycle methods like mount, unmount, bootstrap, etc., which they have to individually implement it so that it can dictate their own behavior inside the document object model. And then we also have routing. So a single SPA can load micro frontend based on the URL paths. And we also need to implement the routing inside each independent micro frontend in general. Now that we have talked about the strategies, we can move on to the challenges that micro frontends bring. Micro frontends are a very powerful architecture pattern, but they have distributed nature because are highly distributed. That introduces a unique set of challenges. And for all the developers, it's just crucial to know what these problems are so that we can have an advanced and a clean strategy to solve those problems. So the biggest challenge that comes with the micro front end is, of course, the inconsistent UI UX. With so many teams, different teams working on different parts of the application, maintaining a uniform look and feel across the entire application becomes a significant challenge. We can have styling conflicts where different teams might use different CSS frameworks or methodologies, like one team is using Tailwind, the other team is using Material UI. And this can lead to style overrides, class name collisions, and all disjointed user experience. We can also have this inconsistency can result in differences in user interactions, design patterns, and accessibility standards. This can be a jarring experience for the front end and harm the brand's perception. Okay, so there are a few solutions that we can do to kind of combat these challenges. This particular challenge, which includes a shared design system and a scope styling, so that um, a shared design system is the most critical fix. A dedicated team or a core group of developers should own a centralized and a versioned design system. So this system should be published as an npm package, and it should contain all the shared components like tokens, colors, typography, spacing, styling rules, everything. And all micro front ends must use this single source of truth in their individual independent components. Another challenge that we face are integration and orchestration complexity. So this is a core challenge in how to compose independent applications into single cohesive user experience, right? This includes routing and asset management in particular, because each micro frontend can redirect to a different route, and two micro frontends can eventually redirect to the same route, which can have a routing override. So routing conflicts or dependency hell, where micro frontends are defining the same URL paths. For example, one micro frontend has slash settings and another one also has another route with the same name. It can what happen is that they can override the entire router. And each micro frontend can also have its own bundling of a shared library, for example, React, leading to larger bundle size and potential runtime errors. Um, the best solution for this problem is to use module federation or a native federation. This is like a gold standard solution which allows you to dynamically load code from a remote micro frontend to a host shell application at runtime. Crucially, it manages shared dependencies for you, ensuring that only one version of a library like React or Lodash is loaded. This drastically reduces the bundle size and avoids version conflicts later on in the application. To combat the uh, route override problem, we can have centralized routing. So implementing a centralized routing map within the host shell, which means that whatever application is handling the micro front ends, that application should have its own global route, and the applications should follow the same route. So each micro frontends register its routes with a unique namespace to prevent conflicts, and this registration should be done in the shell or in the host application that is considered to be the single source of truth for navigation purposes. Then yes, we have cross micro frontend communication and state management. When what happens is that when um, we have so much loose coupling, and when loose coupling is one of the goals to implement micro front end, um, they still need to communicate with each other. And without a proper strategy, this can lead to an inconsistent data state. For example, synchronized login statuses or something like that. And tight coupling through brittle and ad hoc solutions like window events. What you can do in this scenario is that you can implement an event bus or a pub sub pattern. And this is for now, this is like the most elegant solution, which is to a global event bus that allows micro frontend to publish and subscribe to events without needing to know about each other. So for example, an authentication micro frontend can publish a user logged in event, and other micro frontends can listen to that event. For the state management problems, we can have a centralized global state. For example, a limited set of truly global data like authentication tokens or user preferences, we put them in a centralized global state to or like a store like an NGRX that can be implemented in a shell application. So another common solution to that can be an API contract, in which all communication, whether via events or direct API calls, must be governed by clear, documented API contracts. Now, this is a critical piece to ensure changes in so that the micro frontends, one micro frontend doesn't break another. So that was a little bit of the conclusion. We talked about micro front ends, and how powerful of an architecture pattern that directly addresses the scalability, team autonomy, and technical debt challenges for the monolithic front ends. They allow teams to own their features end to end, enabling them to work faster and more flexibly. However, this all power also comes with its own set of complexities, which requires careful planning and the right tools to combat those challenges, as such as module federation, shared design systems, and a solid communication strategy to manage. Now, embracing the micro front ends means shifting your mindset from a single application to a cohesive system of independent and collaborative products. If we have time, I can demonstrate a small application that I created using Native Federation.
Yeah,
Do
we
we
have
have
a
time?
time, but we
Okay.
have a time, but we have a three question from a mic. First,
Okay.
can we just answer these questions?
Oh, yeah,
Okay,
sure.
first question is what are the main problems that micro frontends solve compared to traditional monolithic frontend?
Okay. So, like we discussed, there are many problems that traditional monolithic front ends bring, like tight coupling of the components. So the components are very tightly coupled. We have scalability issues. Monolithic front ends are not generally very scalable. We also have slow deployments and development life cycles, and we do not have team autonomy in a monolithic front end architecture. So these are the four problems that are very, very common, and they actually improve the developer's experience. And micro front ends addresses these problems in a greater detail.
Okay, second question is how do you manage cross-cutting concerns like authentication, logging, or analytics in micro frontend setup?
Can you repeat the question?
Yeah. How do you manage cross-cutting concerns like authentication, logging, or analytics in micro frontend setup?
Okay, so for the authentication and authorization, what we can do is we can manage the user login state. We can manage the permissions and the security in a global manner. For the routing and navigation, we can handle navigation between different micro front ends and manage overall application URL structure. For the state management, we can share a global state management. We can integrate a global state management library that can combat this problem, and we can have a single source of truth for the state. So yeah, I hope that answered the question.
Yeah, okay. And the last question is, do you see micro frontends becoming a standard practice in front-end development or just
That
a
is a
solution for very large
okay.
application app?
Okay, so I think that is a very good question. Both the answer is yes and no. There are certain scenarios where micro frontends do solve a lot of problems, but micro frontends are not something that can be applied to every other architecture and every other solution because of the complexities that they bring. And sometimes what happens is that the overall complexity increase the overall complexity outweigh the potential benefit that we are assuming that micro-fronted architecture would bring. So micro-fronted is awesome, but just like microservices, if it is implemented in an incorrect manner, or if it is implemented in a use case that didn't really require the micro front ends in the first place, we can have a lot of problems in the micro front end architecture. So I don't think that uh, maybe for very large scale enterprise application that have teams that are geographically located and are independent, and they require very fast rapid development and deployment, this is a scenario where yes, we can implement micro front ends, but it is not something that every industry should follow, and definitely not something that is always guaranteed to give you the benefits regardless, if it's not, especially if it's not applied in a proper use case.
Okay, you can just show us the practice part.
Okay. So yeah, this let me just go through this entire application first, how this application is designed. Let me. Okay, so okay, so as you can see, this is our shell application. This is one micro front-end application that has a fancy poster of K-pop demon hunters, which is something that I'm hooked on to these days. This is another micro front-end, which contains another image that is Taylor Swift just got engaged. So yeah, this is also something. um if I show you that these both applications are two separate applications. So one application is running on 4201 and the other one is running on 4202, right? And in this shell application, we have contained both the micro frontends in one singular host. And this is done with the help of Native Federation. What I can do is I can show you the code as well. All right, so let me just quickly show you what the project is uh, doing and the different components. So we have three. This approach follows a very simple background. We have a shell that is containing two micro frontends, right? We have MFE1 and MFE2, which we just saw here. We have MFE1 and we have MFE2. Okay. So each application, as you can see, has its own code base, and in production environment, um, they will have their own CI/CD libraries, CI/CD pipelines as well, right? Uh, if I take a look at the federation file, yeah, so this tells us where to find each micro front end. Sorry, um, this is the file that has initiated the native federation, right? And if we go into federation manifest, this file tells us where to find each micro front end. So micro front end 1 we can find here, and micro front end 2 is placed here. Okay. If I show you the routing of the shell, we can see that we have MFE1 and MFE2 for loading in each individual micro front end. So yeah, the whole point of this application was to demonstrate that each micro front end is truly an independent application. So changes in one micro front end will be reflected in the in the overall application. Um, right. The shell or the host application is the one that is orchestrating everything. Um, and all the communication between these two micro front ends are handled in the shell independently. So yeah, that was a little bit about the overall application, the architecture, and how this application scales up in the micro front end architecture. So I hope it was helpful. And yeah,
Mm, okay, thank you very much. So, yeah, we can now finish our talk. So
okay. So yeah,
thank
it
you
was
so
great
much,
being here.
everyone. Yeah, thank you so much, everyone, for joining today, Angiaza. Especially thanks for Mike. A huge thanks to our speaker, Ingila Ijas, for sharing such valuable insight on micro frontend architect, from why it's matter to how it's scale and the strategy we can apply in real projects. We hope today's session give you fresh ideas, practical takeaways for your own development journey. Don't forget to subscribe our YouTube channel and follow us on social platform to stay updated to upcoming NJ Asia events. Until next time, keep learning, keep building, and keep growing with Angular community. See you at the next NJ Asia. Thank you very much.
Okay, is it ended?
Uh,